Hey guys, and welcome back to another video on the channel. In today's video we're going to be taking a look at an introduction pretty much to polynomials. So a polynomial is pretty much any algebraic expression where you can have like x squared, x cubed and stuff like that. So this is their basic definition, what they have here. It looks very complex at the moment, but pretty much all it's saying is a polynomial can be written in this form like this. So in other words, anything with a power to x. So for example, x squared, x cubed, x to the 4, x to the 10,000. These are all polynomials pretty much. So anything with x's, squares, or stuff like that, that's a polynomial. So you've actually already dealt with polynomials if you've done quadratic equations or linear lines. They're just different types of polynomials. So usually you deal with, when you think of polynomials, you think of a cubic, but actually a line and a quadratic are both polynomials. They're just lower degrees. So a degree of a polynomial is pretty much its power. So for example, x is a degree of 1, x squared is a degree of 2, and x cubed is a degree of 3, and it keeps going on, and that's what they'll pretty much mention here. So a polynomial has the function, can be written in the form like this. So this is pretty much the highest power of this polynomial, and what this pretty much means is the ascending power. So for example, if n was 4 here, then this term here would be 3 because it's n minus 1, and so on and so forth until you get a linear term and then plus a constant pretty much, okay? So that's what that pretty much means there. It's like, alright, the highest power you have here in ascending order pretty much. So for example, generally if you have a quadratic, you write it like this in ascending order. So the polynomial is the x squared is your leading term, then it would be a linear term, and then it's your constant. It's pretty much what they've got written here, in other words, pretty much. N is a natural number, or 0, and the coefficients, blah blah blah, all that stuff there. And the number 0 is called a zero polynomial. I don't know why we need that. That's kind of useless. The leading term xn of the polynomial is the term with the highest index among the terms of the non-zero coefficient. So pretty much that saying is if you have x cubed, x squared, and x just x in your polynomial, your highest one is x cubed. So you start with that pretty much. So that's the more dominant of the polynomial, and that's the degree you determine it as. So for example, if I have x squared plus 4x plus 3, it's got a degree of 2, but as soon as I add in a 3x cubed, it now has a degree of 3. So the highest term pretty much. Degree of polynomial, they mentioned that there. Monotonic polynomial is a polynomial whose leading term has a coefficient of 1. That stuff's, not gonna lie, it's kind of useless, but it's just good to know anyway if they want technical terms on that. But let's get straight into it pretty much. So let's just practice with some polynomial stuff. So example 1 I picked out of a textbook where they've got p of x. Now they like writing it like this in function notation. Another way they can write it is f of x, but most of the time you'll see it as p of x. Mainly for long division eventually. What this activity is doing is pretty much getting in the idea that you can plug in numbers into this equation. So this is a polynomial with a degree of 4 because it has a quartic term. So x to the power of 4 is your highest term there. Even though there's a cubic, the highest term is to the power of 4. Okay, so p of 1. So that pretty much means is when x equals 1, what is that pretty much? So p of x is x to the power of 4 minus 3x cubed minus 2. So therefore p of 1 means wherever there's an x, you need to replace that with pretty much a 1. So for example, this will be, alright, 1 to the power of 4 minus 3 times by 1 cubed minus 2. So we can see wherever the x was, I replaced with a 1 now, and now we just got to evaluate what that is. That will be 1, that will be minus 3, minus 2. So what we're going to have is minus 4 as our answer. So that would be minus 4. P of negative 1, exact same thing. So all we got to do is write p of x again, except we've just got to substitute in x equals negative 1 now. So I rub that out, and I'll rewrite that first bit. So p of x is x to the power of 4 minus 3x cubed minus 2. P of negative 1, p negative 1, wherever there's x, substitute negative 1. Now the only thing that's going to change now is this term here, because this is an odd power, so you're going to have a negative number here. But wherever the x was, I just replaced with pretty much a negative 1. So p of negative 1, still don't know what that is. This is going to be positive 1 because that's an even term up there, so it'll be 1, and this will be odd, so this will be negative 1 times by negative 3, which is positive 3, minus 2, which gives us 2. So that is the answer for p of negative 1. And it's the exact same thing with these other ones here. So p of 2 will be 2 to the power of 4 minus 3, 2 cubed minus 2. 2 to the power of 4, we can evaluate that because 2 squared is 4. So that means 4 times 4 would be 2 to the power of 4. So that would be 16. So that would be 16. 2 to the power of 3 is 8. So it will be negative 3 times by 8 minus 2. So we get 16 minus 24 minus 2. So we get 16 minus 26 gives us negative 10. So that will be negative 10 in that case there. And then the exact same thing with p of negative 2. So p of negative 2 will be negative 2 to the power of 4 minus 3 negative 2 cubed. And the only thing that changes here is this bit here. This will be negative still. So it will be positive 24 minus 16 minus 2. So that's going to give us negative 18 plus 24, which I believe is 6. So that will be the answer for that one there. Very basic stuff like that, but practicing little things like this helps it so much with your algebra because it gets in the idea, alright, you input a number, you get out another number pretty much. So it's idea about pretty much just a function. A function requires one input, gives you one output. So it's a good idea just to practice these ones, even though they're very basic. Don't do more than 6, but yeah, have a go at stuff like that. Let's take a look at this next example that I've picked out. So it's got pretty much 2 parts. So this one is very similar to the idea of what we were just doing before. So the reason we did this one first is because, well, we're going to need this information and this method to solve pretty much this next question. So let p of x equal 2x to the power of 4 minus x cubed plus 2 times c times x plus 6. If p of 1 is 21, find the value of c. Okay, so let's just do a first. So a. So what we've been told is, alright, p of x is this. But we've got an unknown in there that isn't x. We've got this c value. But we can actually work it out because we've been given some information about the polynomial. You've been told that p of 1 is 21. So that means when I substitute x equals 1 into my polynomial here, this whole thing will be equal to 21. So in other words, you can write it as p of 1 equals 2, 1 to the power of 4 minus 1 cubed plus 2 times c times 1 plus 6. And now you can replace this bit here with 21 because that's what they defined it as. So you can go, alright, 21 equals, this bit's going to be 2, this is going to be minus 1, this is going to be plus 2c plus 6. Now you've just got to solve for c. So that's going to be 2c plus 7 equals 21. So we're going to have 21 minus 7 equals 2c. So we're going to get 14 equals 2c. Divide by 2, divide by 2, c equals 7. Okay? And you can double check that because if you put it back into here, you'll get, alright, p of x is going to be wherever that c was, you put that 7 now. So you can get 2x to the power of 4 minus x to the power of 3 plus, alright, 2 times c is 14. So you have 14x plus 6. Now if you substitute x equals 1, you should get 21. So you're going to go p of 1 gives you 2 to the power of 1 to the power of 4 minus 1 to the power of 3 plus 14 times 1 plus 6. So what we're going to get here is 2 minus 1 plus 14 plus 6. So in other words, we're pretty much going to get 14 plus 7, which gives you 21. And we can see we've got the correct value of c then because we matched our initial condition here. So that's why you need to practice stuff like this in case they give you a question pretty much like A here. Okay. Now, B is a bit of an extension, but let's take a look at it anyway. So let's rub this stuff out and let's get pretty much straight into it. Righto, so B, Q of x equals 2x to the power of 6 minus x cubed plus ax squared plus bx plus 20. So we can see the only difference about this question is instead of one unknown, we have two unknowns, a and b. So, but now we've also been given 2 initial conditions. We've been told, alright, Q of negative 1 is equal to Q of 2 is equal to 0. So in other words, what this pretty much means is, alright, when x is equal to -1, q equals 0. And when x is equal to 2, q also equals 0. So the way they write that is, alright, q of -1 is 0, q of 2 is 0, and because they realize, oh, these are the two same things, we can just write it like this, pretty much. Because they're the same thing and they're both equal to 0. 0 equals 0 equals 0, pretty much. That's what they've got there. Okay? So, now we know what that means. We're pretty much going to get two simultaneous equations, pretty much, because we have two unknowns. So if you've got two unknowns, you'll need two equations, pretty much, to find it. So, I'm going to write out q of x. So q of x equals 2x6 minus x cubed plus ax squared plus b. Now I'm going to write capital B because they otherwise look like 6's, my lowercase b's. So I'll use capital B plus 20. So first of all, I'm going to sub in my initial condition, this one here. So q of -1, and wherever there's pretty much an x, you substitute in that -1, okay? So this is going to be, alright, 2 brackets -1 to the power of 6 minus -1 to the power of 3 plus a -1 all squared plus b -1 plus 6. Now you notice I included brackets everywhere because this power is affecting the -1. You cannot exclude the negative sign because of the power. So this term here, it's even, so you're going to get 2. This term's odd, so it's going to be -1 times -1, so it's going to be +1. Here you're going to have positive a, and here you're going to have minus b plus 20. Now we're told this is equal to 0. So at the moment, if I combine all my stuff, I'm going to get, alright, a minus b plus 23 equals 0. And that is equation 1, pretty much there. So we've got a in terms of b and some number here, nothing else, no x's. So all I'm going to do now is get rid of this stuff and do the same thing with the second initial condition. So I'm going to move this guy up here. Now we substitute, alright, q of 2 gives me 2, and wherever the x is, you place the 2 to the power of 6 minus 2 all cubed plus a on 2 squared plus b 2 plus 20. So now we go evaluate this pretty slowly. So this first bit, 2 to the power of 6, is the same as 2 to the power of 3 times 2 to the power of 3. 2 to the power of 3 is 8, so in other words, we've got 8 times 8, which is 64. 64 times by 2 is 128, so you get 128 minus 8 plus 4a plus 2b plus 20, and that is all equal to 0. So now I'll rub that stuff out. And let's see if we can simplify this. Now we can see, before we even evaluate anything, we've got pretty much 4a plus 2b, 28 minus a is 120, plus 20 is 140, 140 equals 0. Now you can see they're all factors of 2, so if you really wanted to, you can divide the entire equation by 2, so you can get, alright, 2a plus b plus 70 equals 0. They're exactly the same thing, one's just a scalar multiple of the other. So this is equation 2 now that we will use. Let's write that stuff out now. Let's move that up here, and let's pretty much try and solve for a and b now. So when solving simultaneous equations, there's two methods you can use, substitution or elimination. Now in this case here, I'm going to use elimination because if I look at my two equations here, if I were to add both of them together, I would get, alright, 3a, and this would get cancelled out. So I get 0b plus, alright, 23 plus 70 is going to be 93 equals 0. So that's gone. So in other words, we get 3a plus 93b equals 0. So what I did was, alright, 1 plus 2 gives me 3, and this is my equation 3. Then we move the 93 to the other side, so we have 3a equals negative 93. Then we divide by 3, so a equals negative 93 on 3. I'm not fully sure what that is, I'm going to check my calculator. 93 over 3 is 31, so a is negative 31. So there's the value of a. Now we just substitute that into either equation, so we have, alright, a minus b plus 23 equals 0. So now we're going to pretty much solve for b, move the b to the other side. So a plus 23 equals b. We know a is negative 31, so negative 31 plus 23 equals b. What is that? 23 minus 31, negative 8 equals b. So I got a equals negative 31 and b equals negative 8. Now we can double check that with our initial conditions now. So I've rubbed this stuff out. So our polynomial, we can see we've got a and b here. So our actual polynomial, q of x, is 2 to the power of 6 minus x to the power of 3 minus 31x squared minus 8x plus 20. So if I substitute x equals negative 1, I should get 0 now. So q negative 1 gives me 2 negative 1, 6 minus negative 1 to the power of 3 minus 31 negative 1 to the power of 2 minus 8 negative 1 plus 20. So what we're going to get here is, alright, 2, and that's going to be plus 1. This is going to be minus 31, and this is going to be plus 8 plus 20. So we're going to have minus 31. 8 plus 20 is 28, plus this is going to be plus 31, and we get 0. So that first bit is correct. So now we got to check, alright, when x equals 2, we should get 0 as well. So q of 2 gives me 2, 2, 6, minus 2 cubed, minus 31, 2 squared, minus 8, 2 plus 20. So what we're going to get is, alright, 2 to the power of 6 times by 2 is 128, so 128 minus 8. Then we're going to get, alright, 4 times 31 is going to be minus 124, minus 16 plus 20. So let's see what we get. So 128 minus 124 minus 8 minus 16 plus 20. What is that? I think that's 0. 128 plus 128 minus 124 minus 8 minus 16 plus 20. Yep, that's 0. Alright, that works. So both of them work, so we know we have the correct answers of A and B. Alright, let's move on to the next example. Right, so this will be the last example for this video, and then we'll do a part 2 to this one. Now this isn't all the polynomials done, this is just an introduction really into it. So, example 3, p of x equals x cubed minus 6x plus 3, and q of x equals x squared minus 3x plus 1. Find a, p of x plus q of x, b, p of x minus q of x, and c, p of x times q of x. So, first one's really easy, so a, p of x plus q of x gives me, alright, x cubed minus 6x plus 3, so this here is my p of x, and then my q of x will be plus, alright, x squared minus 3x plus 1, and that's my q of x there. So we pretty much look for like terms. So there's no other cubic, so we leave that, and there's no other x squared terms. So at the moment we've got, alright, x cubed plus x squared, and now we can see this is a like term. So we have minus 6x minus 3x will give us minus 9x, and then we have 3 plus 1 gives you 4. So that is the answer to pretty much A. Alright, B, so p of x minus q of x. So pretty much we attach a negative sign for on the whole thing, so you can have x cubed minus 6x plus 3 minus, and then brackets around the entire thing, so x squared minus 3x plus 1. Distribute that negative, so you're going to get x cubed minus 6x plus 3. Distribute that negative to every single term, minus x squared plus 3x minus 1. So x cubed minus x squared minus 3x plus 2, and that is the answer to pretty much B. Now we're going to take a look at C. So C is a bit more complicated because it's multiplication, but it's still doable, pretty much. You just got to take your time with it and do every term separately and not try and do too many things at once, if that makes sense. Right, so P of x times by Q of x. So in other words, just write both of these expressions in brackets. So x cubed minus 6x plus 3 multiplied by x squared minus 3x plus 1. Now, I don't like to do the FOIL really. I like to just write it a bit differently. So it's going to be this term multiplied by that whole bracket. So why don't we just write it down here? So it'll be x cubed multiplied by that whole thing. X squared minus 3x plus 1. Then you're going to go plus, and then the next term, which is negative 6x, also times by the whole bracket. X squared minus 3x plus 1. And then you're going to go plus the next term, which is 3, times by the whole bracket again. So x squared minus 3x plus 1. Righto. So now you do distribution of all these guys here. So let's see what this first bit gets. So this will be x cubed times x squared using your index laws. That gives you x to the power of 5. Here this is going to be minus 3x to the power of 4 plus x to the power of 3. Then we do the same thing here. So negative 6x times by x squared will be minus 6x cubed. Negative 6x multiplied by negative 3x is going to be positive 18x squared. Negative 6x times by 1 is going to be minus 6x plus, and then you do the same thing down here. 3 times x squared is going to be 3x squared. 3 times by negative 3x is going to be minus 9x. 3 times by 1 is, of course, 3. Now that we've done that, we look for like terms. There's no x to the power of 5, that's your highest degree, so it's a polynomial with a degree of 5. No other quartic terms I see, but there's a couple cubic terms. So we've got here, here, and do we have any others? That's about it. What else do we have? We have x squares, and we have x's. So notice how I highlighted them in different ways. I put bars underneath the cubes. I circled the x squares in red, and I circled the x's in black, so I could highlight them differently. So your answer is going to be, let's rub this stuff out so I have enough room. So it's going to be, alright, x to the power of 5 minus 3x to the power of 4. The cubics, x cubed minus 6x cubed is going to be minus 5x cubed. 18x squared plus 3x squared is going to be 21x squared. Minus 6x minus 9x is going to be minus 15x plus 3. And that is the result of P of x times Q of x. Righto, I hope you enjoyed this video. This is a part 1. There will be a part 2 where I'll cover pretty much this last example and then these following questions. But yeah, stay tuned for that, and I hope you enjoyed this video. If you have any questions, leave some in the comments and I'll try my best to answer them.